In this lesson, we take on solving inequalities and compound inequalities. Basically, the only difference between solving an equality and an inequality is that whenever we take and multiply or divide an equation by a negative, there's no effect. However, with an inequality, if we divide or multiply by a negative number, it flips the inequality sign. So in this example, the first thing we'd want to do is we'd want to take and distribute this 3, just like we would in any other problem we do. So we have 5 minus 6x plus 21 greater than or equal to 30. Combine like terms, so I have negative 6x plus 26 greater than or equal to 30. Subtract 26 to both sides. No change, because I haven't multiplied or divided by a negative number, giving me negative 6x greater than or equal to 4. Then I'm now going to divide by negative 6 to both sides. Since I'm dividing by a negative number, we end up with x is less than or equal to negative 2/3. Notice inequality switched. Now you'll notice this problem asks us to graph on a number line and then state the answer in this thing called interval notation. X is less than or equal to negative 2/3 is inequality notation. On a number line, we put a negative 2/3 filled in circle for less than or equal to, and then an arrow going this way. So that's my number line. For interval notation, what we do is we want to say all the numbers less than negative 2/3. So negative 2/3 is our highest term, and it goes all the way down to negative infinity. So you start with your lowest term, move to your highest term. Since negative infinity can't be defined, we give it a parentheses, and since negative 2 is included, bracket. This is included. This means not included. And the only reason that negative infinity is not included is because we can't define it. All right? And we'll continue some more examples with interval notation so you understand what's going on. So here's another example where we need to solve this and then state the answer in interval notation. I'm going to distribute both these terms. I get 12x minus 3 strictly greater than 12x minus 10. Notice, getting all the x's to one side of the equation, my x's go away. So this is kind of a special case. I have negative 3 is greater than negative 10. I have no x values in the problem. So what I'm either going to end up with when I lose my variables is a true statement or a false statement. Is negative 3 greater than negative 10? Yeah, that's true. If I end up with a true statement, then my answer is all real numbers. So that, on a number line, would be the entire number line from negative infinity to infinity. Right? In interval notation, to say all real numbers, you go negative infinity to infinity. Notice the two parentheses since neither infinity can be defined. When we talk compound inequalities, we're talking about two specific words, and or. And talks about an intersection or an overlap, and or talks about the union, which is a fancy name for everything that you see. We're going to solve and graph two simple compound inequalities. One, x is greater than 2. That's how I would graph this. And x is less than 7. So here's 7, and I go this way. Now what we want to do is we want to take, and since it says and, I'm looking for the intersection or overlap. Where does this overlap? It overlaps from 2 to 7, and since neither is included, I get open circles. If I state this in interval notation, I would start at my low number, which is a 2, go to my high number, which is a 7. Notice the 2 parentheses because neither the 2 nor the 7 is included. If they were included, I would use a bracket. In this case, I have x is greater than 4, strictly greater than, so open circle. X is less than -1, strictly less than, so open circle. And now I want to state my answer as everything that I see. Well, this is everything I see. So in order to state that in interval notation, I have actually 2 intervals I have to state. I start with my low number here, which is -infinity, and move to -1. Since neither is included, they get parentheses. Then I'm going from 4 to infinity, and since neither of those is included, I use, once again, parentheses. And to state I need both of these, I put this U right here, which means union. So here are some special cases for compound inequalities. If I have x is less than 2, here's 2, less than moving this way. X is greater than 4, 4 going this way. And I have an and, there's no overlap or intersection, so there's no solution here. If I take a look at 5 and going greater, and 6 and going less, notice this is not an overlap equation because it states or. It says state everything you see that is graphed. Well, if I go from 5 all the way to infinity, and I go from 6 all the way to -infinity, basically my entire number line is being covered. So I have all reals in this case. And in interval notation, that goes from -infinity to infinity. And since neither can be defined, 2 sets of parentheses. Lastly, I've got a 2 and greater than, and a -4 and greater than. And I want to state everything that I see in its simplest possible form. So notice if I go 2 all the way to infinity and -4 all the way to infinity, just saying x is greater than, greater than -4 covers all my bases. So I can say my smallest number is -4, I go to infinity, and since neither number is included, parentheses. Now we're going to solve some compound inequalities, and this is just like solving inequalities, except we have to consider this statement at the end and link our answer to our graph. So in this case, I'll subtract 5x to both sides. I have 3 is greater than -x, divide by -1, which means I'm going to flip my inequality sign. And then over here, I'll distribute. And combine like terms. Subtract 3x. And divide by -1. This flips my inequality, like so. Now I want to graph this. I have a -3, not included, so open circle, and it's greater than, I have a negative 5, and all values that are less than that. So here's my graph. Always put your or between these two statements of your answer. And then if I put this in interval notation, my small number is negative infinity. Large number is negative 5. Neither are included. My small number is negative 3 to the right. My big number is infinity. And I need to say or, so I need to show everything. So I want to union that. And that's my final answer. Now we've got an intersection problem because of the and. So let's go ahead and distribute through. We have 2x minus 10 greater than or equal to 2. Add 10 to both sides. 2x greater than or equal to 12. Divide by 2. And then we have 4 minus 9 plus 3x greater than 3. This is a negative 5. Add 5 to both sides. 3x greater than 8. Divide by 3 to both sides. And x is greater than 8/3. So again, let's take a look at what we have. I have a 6, like so. And I'm going to fill that in because it's equal to, and go greater than, so we go to the right. And I have an 8/3, which is less than 6. So I'll put that over here. That's an open circle, and this also goes to the right. Now, this problem states I'm looking for an overlap because it's an and. Where do these overlap? Well, they overlap from that 6 on. So really, my final solution is everything that's overlapped, or x is greater than or equal to 6. To state that in absolute value, I start at my low number, which is a 6, go to my big number, which is an infinity. Since infinity can't be defined, it gets parentheses, but since 6 is included, that gets a bracket. Now, sometimes compound inequalities can be written as follows. This says, find all values such that 2x minus 7 is both greater than or equal to negative 15 and less than or equal to 9. If I really wanted to, I could split this up into an and problem. I could say negative 15 less than or equal to 2x minus 7 and 2x minus 7 less than or equal to 9. Not really my choice. I wouldn't do it that way because I can solve this a little bit easier by doing the following. I can take and work this like a normal equation, but work it from two sides. So I'm going to add 7 to both sides of the inequality. Thus, I've got negative 8 less than or equal to 2x less than or equal to 16. Now again, I would divide by 2 to get x by itself, but I do it to two sides. Therefore, negative 4 less than or equal to x less than or equal to 8. And this is a satisfactory solution, and it says graph all the numbers between 8 and negative 4. Well, here's negative 4, close circle, 8, close circle, connect the dots. In interval notation, small number, negative 4, large number, 8, both are included, two brackets. One last example. This is a little more difficult because in this case, I can't work both sides of the inequality because when I bring an x over here and then bring an x over here, there's no way to isolate an x in the middle. So what I have to do is, in this case, I do have to split this up into two inequalities. I have to say 6 minus 3x greater than or equal to 4 minus 2x, and 4 minus 2x greater than 5 minus 4x. I'll add 3x to both sides, subtract 4 to both sides, giving me 2 greater than or equal to x. In this case, I'll add 4x to both sides, subtract 4 to both sides, end up with 2x greater than 1, divide by 2, x greater than a half, and this is an and. So here's my 2, closed circle because it's included, arrow going this way. Here's a half, open circle, going this way. I want to take and graph the overlap, which goes from negative half, or positive half, sorry, with an open circle, to 2 with a closed circle. In interval notation, small number a half, large number 2, 2 is included, gets a bracket, half is not included, gets a parentheses. Given that, we're done. So make sure you do the assigned problems and fill out your lesson summary, and we'll chat more tomorrow.